Hello everyone, I Professor Bhavik Kumar M. Kataria welcomes you into the video series of operating system, and we are discussing unit number 2, process management. In our last session, we have discussed process scheduling and CPU scheduling as well as various types of scheduling techniques. So guys, if you are still remain to watch that video, so you can click on I button at top right corner and you can watch the video of previous session. Today we are going to discuss first scheduling technique, that is first come first serve. So let's start without wasting the time our first algorithm of process or CPU scheduling, that is first come first serve scheduling. FCFS scheduling is basically working in non-preemptive mode. My dear friends, there are two modes. One is preemptive mode and second one is non-preemptive mode. In case of preemptive mode, we can preempt the process in between the execution. Whereas in case of non-preemptive mode, we can't preempt any process in between the execution. So, uh, first come first scheduling algorithm is working on non-preemptive mode. It means whenever we will start any process, suppose if there is a process P1, so whenever process P1 is in execution, so we can't stop process P1 before completion of the entire execution. Whenever process P1 will completely done their entire work, then and then another process P2, P3 or P4 can start their execution. So common fundamental is there, whenever any process is in execution, so we can't stop that process in between the execution. That mode is known as a non-preemptive mode. And criteria which is followed by first come first scheduling algorithm, that is arrival time. It means whatever the process will arrive first, that process is going to be served first. Look like a restaurant. Whenever you will go for the lunch or dinner at any restaurant, so they are serving as a first come first serve basis. So let's start with the one example. So here we are going to take 5 different processes, that is P1, P2, P3, P4 and P5. Two parameters given for these 5 processes are arrival time and burst time. Arrival time, it means we have already discussed parameters of process in our earlier video session. Arrival time means uh, arrival time representing whenever process arrived into the ready state. It means at that time processes are ready to execute. Look like arrival time of train and departure time of train. Arrival time means whenever train is arriving at station or platform, that time is known as arrival time. Same thing is here in process. Whenever processes are ready to execute in the ready state and processes are arriving into the ready state, the time is known as a arrival time. Another thing that is given, burst time. It means look like a total journey time. Suppose for the process P1 arrival time is 0 and burst time is 4. Here one notification is that consider all timings in millisecond ms. So arrival time is 0 millisecond and burst time is 4 millisecond. It means, for example, any process is arriving at 7 p.m. So that process will, if that process will start their execution at 7 p.m. so that process will complete 7 p.m. and 4 minutes. Get it? Now what we have to find out here, so let's see. Instruction is given to find out average turnaround time and average waiting time. So to find the average of turnaround time and waiting time, first we will find the individual turnaround time and average waiting time for all 5 processes. And for doing this, we have to draw the Gantt chart. So let's start drawing a Gantt chart. It is our data given to us is in example, and criteria we have to follow, that is arrival time. So first process arrived at time 0, and that was P1. So first process P1 will execute. So let start drawing Gantt chart from the timing 0 and P1 is in execution. And burst time of P1 is 4 milliseconds. So after next 4 milliseconds, P1 will complete their execution. So here we are writing 4. It means 4 milliseconds is a completion time of P1. So here one column is there about the completion time. So we will note down the completion time here after completion of every processes. So let write the 4 here. Next process, that is P2. P2 arrived at 1. It means whenever P1 was in execution, at that time P2 was arrived at 1 millisecond, somewhere here if you are looking the cursor. But at that time P1 was in execution, so we are not going to stop P1 in between the execution. P2 will wait till the completion of execution of process P1, then and then P2 will start their execution. So now at a 4 millisecond, P1 already completed their execution. So now P2 will start their execution from the 4 millisecond, and burst time of P2 is 3 milliseconds. So 4 plus 3, P2 will complete their execution at 7 milliseconds. So 7 millisecond will become the completion time for process P2. Get it? Next, that is process P3. P3 was arrived at 2, somewhere here when process P1 was in execution. So same thing, P3 was in waiting state. Look, like whenever we are going to the restaurant for lunch and dinner, and suppose there is no availability of any table, so we are sitting in waiting queue, get it, or waiting hall. So same here, remaining process will stay into the waiting queue, and whenever earlier process will complete their execution, then next process will start their execution. So next process P3 will start their execution from 7 millisecond, and burst time of process P3 is 1. So 7 plus 1 is equal to 8. Completion time of process P3 will become 8 millisecond. Same for the process P4. P4 will start their execution from 8 and burst time is 2. So 8 plus 10, 10 will become the completion time for process P4. Next arrived process, that was P5, and P5 will start their execution from 10 millisecond and burst time is 5. So 10 plus 5, 15. So P5 will complete their execution at 15 millisecond. Now here arrival time was given in sequence 0, 1, 2, 3 and 4, so on. So that's why we are getting Gantt chart in sequence P1, P2, P3, P4 and P5. But whenever suppose this arrival time is different or not in sequence, so you have to take care during the calculation and whenever you are drawing the Gantt chart. Now we will find out the turnaround time. We have already discussed what is turnaround time in our video of parameters of process. So we know that how to find out turnaround time. It is completion time minus arrival time. So let calculate the P turnaround time. So for the 4 minus 0, for the P1 turnaround time will be 3 millisecond. For the P2 completion time 7 minus arrival time 1, so it will become 6 millisecond. For the process P3 completion time is 8 minus arrival time is 2, so it will become 6 millisecond, and same so on for the process P4 and P5. So let write the turnaround time. Next parameter, that is waiting time. Equation of waiting time, that is turnaround time minus burst time. So if you will look for the process P1, so turnaround time is 4 millisecond as well as burst time is also 4 milliseconds. So 4 minus 4, waiting time we will get 0 millisecond. For the process P2, turnaround time is 6 millisecond and burst time is 3 millisecond. So 6 minus 3 will become 3. So for the P2, waiting time will be 3 millisecond. Same thing for the process P3, P4 and P5. So we are writing waiting time for all 5 processes. Now our motto is to find out the average turnaround time and average waiting time. That is already asking by the examiner. So now we will make an average of turnaround time and waiting time. But guys, if you have still any query regarding to the our example and algorithm, first come first serve, so you can ask your questions or queries to me by writing the comment in comment box. So let start calculating the average. First we will make a average turnaround time. So for finding the average, we will make summation of all these 5 digits and we will divide it by the total number of processes. Total number of processes here, that is 5. That is the simple formula to find the average, and that is a simple match. So here we will make summation of all these digits which we already get as a turnaround time. So 4 plus 6 plus 6 plus 7 plus 11 divided by 5. If we will solve out this equation, then we will get 6.8 millisecond. Here you have to write millisecond as a time unit. Next, for the average waiting time, we will make summation of all 5 digits of waiting time and we will divide it by the total number of processes, and that is 5. If we will solve out this equation, then we will get 3.8 millisecond. So as per the question, our answer of average turnaround time, that is 6.8 millisecond, and answer of average waiting time, it will be 3.8 millisecond. So hope you are understanding everything. In next session we will understand the second method or second algorithm, that is known as a shortest job first.